All right, hello and welcome. In this video, we're going to be looking at writing equations of quadratic functions using both the standard form and the vertex form. So just a quick refresher. The standard form of the quadratic equation is ax squared plus bx plus c. So basically, you'll have the x squared and the x term separated, and then the a, b, and c will just represent the coefficients of x squared and x, and then just the extra little constant on the end. And then the vertex form is y equals a x minus h squared plus k, where the h and k are going to represent the vertex point of the graph or the parabola, which of course is the point exactly in the middle of our U-shaped graph. Notice the a is in both versions of the quadratic equation. And so that coefficient is going to be the same regardless of which formula we're using for the particular problem that we're working. So if I'm looking at this first example right here, it's asking me to find the quadratic function with the given vertex and point. So it's giving me a vertex, and it's giving me another point that the graph of the parabola has to pass through. All right, so I've gone ahead and copied down my vertex point and the other point that I need, as well as my vertex form of the equation. So we said that the h and k represent the vertex point. So what I'm going to do first is just replace the h and k with 0 and 0 because those are my vertex coordinates. Again, the h and the k are the x and y from the vertex. The next thing I'm going to notice is that I don't have a value for a, but I do have a second point that my graph needs to pass through. So to figure out a, I'm going to treat this point as the values of x and y. And so now that I've got all of this plugged in, I'm going to go through and simplify my equation as much as possible, and then use that to solve for a. So to simplify, I'm once again going to remember my order of operations. So I'm going to do whatever's in the parentheses first, which means I need to simplify -2 minus 0, which of course is just -2. Then from there, I'm going to do the exponent next. So I need to simplify -2 squared. And so -2 times -2 will give me +4. So I'm just going to switch that next. After doing my exponents, I'm going to multiply. So I notice the only thing being multiplied is the a and the 4. And so, of course, I know that a times 4 would simplify to 4a. Nothing's being divided. When I look for addition, I see 4a plus 0. And I know that doing a plus 0 doesn't change anything. So I can just get rid of that. And I've done all the simplifying at this point that I can do. So now I'm just going to take a equals 4a and solve it to get the a by itself. So now, since I'm solving, I'm going to follow the order of operations backwards, right? So I would look for any addition or subtraction to do first. I don't see any. I see that the 4 and the a are being multiplied, so I can use my division to cancel that out. So by dividing both sides by 4, I'm going to get that a equals 2. And so now that I've got my a, I can go in and plug that into the vertex form along with the h and k. And then I can put the x and y back the way they were because I need an equation that has an x and y in it. And then I now have my equation in vertex form. I could also look at that and realize that the zeros aren't really needed. So if I wanted to, I could simplify that to y equals 2x squared. So either of these would technically be correct. So the next one I'm going to look at is part C. So it's going to be a similar process, only instead of having the vertex at 0, 0, we're going to have the vertex at -3, 0, so we can kind of see how that changes the process. So once again, I've written down my 2 points that were given to me and my vertex form. So now we're just going to go through and substitute. So I've taken -3 and 0 and plugged them in for h and k. And then I've taken the -5 and -4 and put them where the x and y were. And then again, we're going to simplify to get the a by itself. So if I'm looking at the numbers in the parentheses first, I notice I see 2 negatives up against each other with the -3. So I'm probably just going to know that, or remember that 2 negatives switch to positive. And then I'm doing that just to avoid confusion. I'm once again going to simplify in the parentheses. So -5 plus 3 is again going to give me that -2. Next, I'll do the exponents. So -2 squared will change to 4. Then we'll do the multiplication. So a4 can change to 4a. And of course, plus 0 isn't needed, so we can get rid of it. So if -4 is equal to 4a, we can solve that to get the a by itself. So we'll divide both sides by 4 to get that the a should equal -1. And so once again, we're going to go in and put everything back into the vertex form. So where the a is, I'll put a -1. I'll put the x and y back the way they were. And then, just like last time, to kind of clean it up, the +0 on the end doesn't actually do anything, so I can get rid of it. And then if I put -1 here, I technically don't need to write the 1. So the simplest version of that equation would look like this. All right, for our next example, we're going to look at finding the vertex form from an equation that's in standard form. So I'm going to take the equation that I've got right here. Oops. And I'm going to convert that into vertex form. So just a quick reminder, since the standard form says ax squared plus bx plus c, when I write down my formula, I want to make sure that the x squared term comes first, the x is in the middle, and then the constant term is just at the end. And looking at the way they wrote it on the paper, it looks like they've actually given me the equation backwards. So before I start doing anything else, I'm just going to rearrange these terms real quick to put them in order. So here's my equation in standard form with everything in the right order. So now let's write down our vertex form and start plugging in where we can. So the first thing that we'll notice is that the a in front of the parentheses is the same a that's in front of the x squared term. So the first thing I'm going to do is take whatever was in front of my x squared and just write it down in front of the parentheses, so I can put a -1 or just a negative sign. Either one is technically correct. Here I notice that I don't have an h or k given to me. So basically I'm going to need an extra little formula to take the a, b, and c and figure out the hk from there. And that new formula that we need is right here. H equals to -b over 2a. So from my standard form equation, I know that b is whatever number is in front of x, so I'll change that b to a 3. And then a, once again, is the coefficient of x squared. So we'll go ahead and switch that a to a -1, and then simplify that fraction as much as possible. So on the bottom of the equation, -1 times 2 will give me -2. I know when I'm dividing, two negatives make a positive, so the h is just going to be a 3/2. And then to get k, basically what I'm going to do is use that as my x value in the standard form of the equation. So I've taken my original equation and said that k equals -3/2 squared plus 3 times 3/2 plus 8. And then basically we can just punch that up in a calculator and simplify it down and get the value of k. And so when I simplify it down, I get 41/4. So to get the actual final answer, I'm just going to take that fraction, put it in where k was in the vertex form. And so this would be the vertex form of the equation that I was given. And so the other thing I want to do real quick is kind of look at this graph of the equation we were just given compared to the regular x squared parabola, our parent function. We'll notice that with the negative on the x squared, our graph was flipped, right, or reflected. And then we'll notice that the vertex point was shifted to 1.5 and 10.25, which is of course 3/2 and 41/4. Notice that the vertex is shifted to the right and up. So if I was asked to describe those transformations, I would just say it moved right 3/2 of a space. It moved up 41/4 of a space, and then since it's upside down, I would say that there was a vertical reflection. And so for our last example here, we're going to take this graph and figure out what equation would make that graph. So this is very similar to the first problem we worked. Basically what we want to do is write down where the vertex is. So in this case, it would be -1 and 2. And the other thing that we're going to need is a second point. So you're usually going to want to use the y-intercept, but you can technically use any other point that you can see clearly on the graph. So it looks like we're going to cross through the y-axis at -1. So I will use 0, -1 as my other point. And so from here, it's basically the same thing as the first question that we did. So we'll put the -1 and 2 in for h and k. Then we'll put the 0 and -1 in for x and y. And then we'll simplify it down to figure out the value of a. So once again, when I see minus minus, that's going to make a plus. So I change the parentheses to 0 plus 1. I know 0 plus 1 is just 1. I know a times 1 is just a. And then if I subtract the 2 to the other side, that's going to change the -1 into a -3. So to get my final answer, I'll put -3 where the a was, and I'll put the x and y back the way they were. And so here is my equation in vertex form. That's all I have for this one. I will see you guys next time.